For the costing demo, the main requirement you have is to ensure that you've linked in the costing templates. So we can go to File Locations, click Costing Templates, and you've got the path specified to the ones provided in the demo files so that it can reference those. Now the first time you run it on a machine, you are still going to get errors, so it's important to run it once to make sure that errors are handled, because obviously it's saying it doesn't have the path to where these were originally created on my computer. So when you go no, you'll see that when the template comes up, the master template doesn't always have the correct data. In this case, when I was recapturing this, I did save the master template to point to these, but you might have these as asterisks, so just go to the template editor and make sure that these are pointing to the appropriate location. Just something else to keep in mind down here, the weld bead. This is where you specify the standard welds that are detected and mapped automatically. So you can add more here depending on your needs. As far as the rest of the weldment demo goes, not too much to worry about at the top level of the multi-body. Obviously the welding calculations are important, and it shows you with a tooltip the total length of the welds, which is very useful. And if we go and take a look at the individual weldments, the main thing to keep an eye on here is obviously it has the standard sizes available in SolidWorks, and you can see the size tube. Then we have the option for doing costing based on a per unit length or based on stock lengths. And obviously the stock lengths is more realistic, as most people only carry certain stock sizes, and so it will limit how many items you can get out of one piece of stock, or many. So when we change to that mode, you'll see the price immediately updates. That's because it's saying that for stock length 1.22 and a modeling length of 0.84, we're getting quite a bit of wastage. And however, what we can do is if we change to a different stock size, this can also impact our scraps percentage. In this case, the reason it goes up is because we only require 2 bodies, so we could actually get quite a few, 3 bodies at least, out of this stock length, but because it's only requiring 2, we've still got more wastage than we would have wanted. So just something to keep an eye on when you're looking at the numbers is if there's a limited number of parts needed, it might not always be beneficial to adjust to different stock lengths. So other than that, the weldment one's pretty straightforward. With the casting, again, same thing. I haven't saved these since I've opened them on this new computer. Before you go through, make sure that you redefine the metals for the first time and save it. But the main thing we can show here is the ability to cycle things such as the cycle time, the mold cost, or percentage of waste material. So we can, for example, change the mold cost, see that impact the total cost, as well as distribute it over a higher volume of part construction, and see the cost radically reduce. But really the real power is when we start looking at machined cast components. And this instance, what we're going to see is that it's going to initially assume the square block size, which obviously is not realistic. To address that, we now have a new stock body type called custom, where we can use an existing configuration or a separate external reference part if we want to indicate the cast geometry shape. When we click on update, it's going to take the costing information from that casting and then add the machining stuff on top of it, which is obviously what we wanted to do. And there's our additional operations, all nice and neatly. So just be aware of making sure you run through it once to get the appropriate material updated. For the plastics, in this case, the main thing to do is to ensure that you've picked the method as either to do it as plastic or 3D printing Just click on the begin on cost estimation. And once that pops up, then we can take a deeper dive on one of the particular bodies to go through and then do the costing on. So I'm going to pick the center part. So again, just a quick double click. Now with 3D printing, we obviously have a printing volume, and then it depends on how we orient the part as to what the cost will be. For example, if we orient it this way instead, then the cost is going to be a lot higher because there's a lot more layers for it to print. Versus this way, if we've reversed it around, it's not very high, so you've got less layers, and so it should be quicker and hence cheaper. In addition to that, we can obviously right click and pick a different machine or a different printer resolution and see the price update. The template, as mentioned in the demo, is pretty straightforward. Just go down to the machine section, and if you go to the end, that's where all 3D printers are. And really the only difference here is the feed rates and the layer heights. Obviously for the higher quality, the layer height's less, but the feed rate is also less. And then we can change from 3D printing to just injection molded plastic through that second option there. And even though it updates, we've still got a few tweaks to modify it. But again, the workflow is pretty similar to the cast workflow. The mold's a little bit more expensive, of course, but maybe this one's a little cheaper. Again, that's updated and distributed across all of the parts being manufactured. So some great enhancements to showcase in costing.